Hello everyone. Let's start solving this question. Maximum score of the binary, so which came in bi-weekly contest 172. So the question is you are given an integer array nums of length n and a binary string s of same length. Initially your score is 0. Each index I where s of I is 1 contributes nums of 1 to the score. You may perform any number of operation including 0 and 1 operation. You may choose an index I such that 0 less than or I less than n minus 1, where s of I is 0 and s of I plus 1 is 1, and swap these two characters. Return an integer denoting the maximum possible score you can achieve. So, first let's understand this question. Okay, so we are given a string which is binary and one as nums array. Okay, and in binary we have 0 1 0 ones, right? So the length is same. So if it is 0 we are not considering that element. Okay, so let's say we have 1 2 3 4 5 6. So the score is 2 plus 3 plus 6, and we okay, there is one condition, or you can say operation, which we can do to maximize our score. Listen carefully. So, okay, what is the operation? Is we can swap this one with its left side. Okay, not on the right side, left side, because it is given, right? I plus 1 should be 1, and for I it should be 0. Okay, it's s of. That means we can only swap this one on the left side. So if I have 0 0 1, I can swap this to this. 0 1 0, I can again swap this to this. Okay, so first I will explain what I thought after seeing this question is I ignored this. Okay, I just understood that how many the number of ones, let's say k are number of ones. So if I find the k maximum elements, I'll get the max score. But no, but the problem is we can only shift to left if the maximum number, let's say 6, here it was 1 0 6, we won't be considering 6 because still one only, so one can go here. Okay, so this approach is incorrect. Then what I thought is this is the first thing. Okay, then what I thought, okay, I will ignore these elements and I will check the maximum elements after this. Okay, after last one. Then again there was one case. So let's say my string was this 1 1 0 1 0 0, and I have 1 8 8, let's say 3. Okay, so what are the maximum elements? 8 8 3. So I thought there are 3, so it will be 19, but the answer is 17. Why? Because only this one can go on the left, and we will get 8 plus 8 plus 1 is 17. Okay, so this is also incorrect, that thinking number of ones and ignoring this element. So what is the approach is, before getting this one, okay, what are the elements, maximum elements? Okay, so let's take this example understanding this approach is 0 1 0 1 1 2 3 4 5 6. Okay, I have 0. Let's take I'm using some priority queue. Okay, 1. I have this. Okay, this 1. Hmm. Now what we will do is, if we are getting 1, first we will. Okay, what is the answer for this? Consider This is our array. What will be the answer? This one we can swap with this. Okay, it is coming to the left, so answer will be 4 plus 3 plus 2. Okay, so it will be 7. So what I'm saying is 1 is there, and for this we have 2. First we will add. Okay, and I get 1. So what I'll do, I will take the maximum. As we are using the priority queue, let's take in reverse order. So my priority key will be like this. Okay, so we will poll this. So this will be in my answer. Now we will add this 3. Now I also have this one. Okay, so we will poll this, we will add this in answer. Let's take another example. For this example, same. 1 is there, 8 is there. Okay, and now in my priority queue, the in reverse order, okay, it will be sorted. Let's say we have 5, 4, 3, 2, 1. So these are the elements before this one in the string. Okay, before this one, these all elements are there. But for this one we have already, you can consider, taken. So only 1 and 4 are there. Okay, so we can solve in this way instead of going this approach. These are incorrect approach. So whatever approach I'm explaining, that is correct. It will give us a correct answer. So let's take this example itself. 21523 again. 21523, and what is the 01, sorry, 01010 Okay, so in my priority queue I will add 2, I will add a 1. Okay, and I got this one, so I will take the first maximum element in my answer. So before this, what is the maximum element? That is what we are finding. Now we added 5, so 5 will come front. Now we added a 2. Okay, so now it is 5 to 1. Now we add a 2, right? Now we have 1, so I'll take the maximum. So before this one, what is the maximum element? So we have taken this will in our answer. Now we have added 3. This was the last one. So my answer is 7. So if you see, yes. Okay. In this case, there are no ones, so nothing. Okay, so basically what we are finding for this one, what is the maximum element left to this, so it can swap with that. Here we are not asked how many swaps we have to do. Here it is asked the number. Okay, the maximum score. So that is why we are not taking care that number of swaps. Okay, now let's start coding. Is we will be using the priority queue. Okay, to maintain these what to maintain the largest element before that one. Okay, now let's priority queue of integer. Pq is equal to new priority queue, and we want in reverse. So collections dot reverse order. Reverse mean the greater element will be uh reverse. Wait, what I'm doing? Reverse order. Okay, now first we will add and then check if we are getting 1. So what is the largest element before that? So we can swap it with this and we can get that score. So we don't really need to swap. In the question it is asked what maximum possible score, not the swap. Okay, now for int I is equal to 0, I less than nums dot length, I plus plus, I plus plus. Okay, now what we'll do, first we will add pq dot add nums of I. Okay, and then what we will check, if my s dot char at I is equal to 1. Okay, then what I'll do is my score, I'll take long score. Initially it is 0, so I'll add score plus equal to what? We will take the maximum one. Yes, and then we will return the score. Now let's run. So what we did is we maintained the priority queue. So we will get for whenever we are getting this one in the string, okay, in the binary string, we are checking on the left side, because we can only swap with the left side. So we are not really swapping it, we are just considering that one we can combine with the largest element before that one. Okay, so let's submit this solution. Yes, you can see it is accepted. So in this way we can solve this question. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you.